Hello everyone, this is my video on Stackrypt, my computer security project focused on stacking encryption. Stackrypt attempts to solve two significant problems. Number one, encryption keys being compromised. The same way someone might write down a password, people could treat their encryption keys in a similar way. And number two, frequency analysis. Analyzing encryption for patterns to decode is a serious threat to ciphers or similar encryptions. Stacking these with different ciphers can affect the attacker's ability to conduct frequency analysis. I tried my best to solve these in some way, but like anything, my execution can be debated. I made the keys more complex, which would probably just prompt more people to write down their keys. But I also made the decryption of multiple stacked encryptions easier. I leave it to the viewer to decide how practical this approach is, and encourage you to dive deeper into it. Without further ado, let's get into this video. I will start with the software I use to build the website and encryptions. Then this will be followed by a brief walkthrough of Stackrypt. Then I will explain some of the challenges I faced. After discussions with Dr. Wilborn and some classmates, I chose Python and Flask as my micro-framework. Flask allowed me to handle back-end operations and integrate encryption directly using Python's Cipher library for AES, encoding XOR encryption within my Flask file. For the front end, I decided on HTML, CSS, and JavaScript. This choice was straightforward since I had prior experience through an internship and personal projects, though this was my first full-fledged project using these tools. Finally, I needed to determine the best way to handle encryption files. I chose C++ for its speed and used the C++ files as subprocesses in Flask. This setup let me send data from Flask to C++, which would then output the encrypted files. Now that you know the software powering Stackrypt, let me show you how it works. Welcome to Stackrypt's homepage. From the very beginning, I aimed for simplicity in the user interface. I chose a clean color scheme, minimal text, and clear, reactive symbols instead of bold colors or lengthy instructions. The homepage reflects this approach, featuring a title and a drag-and-drop box for file uploads. For this walkthrough, I have a .text file that I want to encrypt. So let's give Stackrypt a try. I'll start by dragging my file into the box. Right away, I'm taken to a new screen with two main areas: the file display and the encryption options. There are also buttons to download the file or upload a new one, but I'm here for encryption, so let's focus on the second column. I see 5 options for encryption, but to keep things simple, I'll just use 2 of them, David and AES. I'll apply one of each. First, I input 1 into the number of times box. Then, I'm prompted to provide the necessary details in a simple drop-down menu. For AES, I'll use a longer key I've already prepared. And for David, I'll use the number 11. Since I'm encrypting, I'll leave the operations box as is and click Apply Encryption. Next, I'm taken to a screen with a draggable stack showing 2 encryption methods I selected. I'll leave the stack as it is, but if I had more layers or duplicates, I might rearrange them to make encryption more complex. Now, I can either go back or continue. I'll click Continue. A success pop-up appears, and after clicking OK, I can see my encrypted file in the file display. But how can I be sure it's not just some random data? Or maybe I lost data during the encryption. Let's test it by decrypting the file. I select David and AES again. Then I input the same keys, the long one for AES and 11 for David. And this time I'll choose decrypt instead of encrypt. Before applying, I'll reverse the order of the encryption stack to mirror the original process, placing AES on top instead of the bottom. Once I click Continue, I'm greeted with another success pop-up. When I click the file, it's back to its original content. Hooray! We finally decrypted this file, and it proves that the encryption worked. Finally, let's test the download feature. I download the file, and it works fine. That's all for this walkthrough. Now, before I conclude this video, I want to highlight 3 challenges I faced. Number 1, a lack of familiarity with the software. This project involved new concepts like Flask, subprocesses, and routes. The steep learning curve was challenging, but ultimately helped me gain valuable skills. Number 2, project scope. I bit off more than I could chew, leading to some necessary sacrifices. Due to time constraints and bugs that couldn't be fixed, I had to abandon features like help buttons, info menus, and multi-file encryption. Number 3, class requirements. I struggled to meet deadlines, and I spent more time coding the product than focusing on class requirements. While there were other challenges, these were the ones that were the most significant for me. However, I went into this project wanting to stack encryption and left with that ability. While yes, there are things I could have done better and aspects I could have spent more time on, in the end, I made a product I'm proud of, had fun building, and helped me grow. Thank you for listening to this presentation. And before you go, I want to give thanks to Dr. Wilborn for teaching this class and Berea College Computer Science Department for giving us a space to interact and learn this material. Goodbye.